Hi everyone, welcome to DecodeWithPriyo, and today we are going to solve the LeetCode number 951. The problem statement is flip equivalent binary trees, and it is the question of binary trees problems playlist, and question number is 1. So what the question is saying? The question is saying that for a binary tree T, we can define a flip operation as follows. There is a tree and the tree name is T, and there is something like left child and right child. What we can do, we can just simply choose any nodes. Suppose that we are choosing this particular node, and we can simply swap the left and the right subtrees. If there is more trees, there is more nodes, then definitely we just swap the whole left subtree with the right whole subtree. Understand? Okay. Now what you'll have to do, the binary tree X is flip equivalent to binary tree Y if and only if we can make X equal to Y after some under of flip operations. Okay, let's understand its mode further. It is saying that you will given a true trees. Number 1 is root 1 and number 2 is root 2. What you'll have to do, you have to check first of all, does these two trees are equivalent or not. What means equivalent? Equivalent means that every node value should be the same of the second tree's values. What am I saying? Suppose that you are standing on the root 1 and you are standing on the root 2 root. Does these two's root values are same? Yes, it is same. Then we can further move. What we can do? We can just simply go to the left child and also the root 2's left child. Now you can see here the 2 and here is 3. Then definitely these two are not equal, right? So what we'll have to do, we just swap the left tree and the right tree. Left tree means left subtree of root 1 with the right subtree of root 1. So let's first of all swap them. Suppose that here is my basically the tree which I have drawn. What we'll have to do, we just simply swap the left whole subtree with the right subtree. So now here you can check that I simply swap the whole left tree with the right subtree. Now what can do? Now we can see that the left child of the root node and the right child of the root node are perfectly same as we want. Now we can move further. So first of all, we just came to the left and again came to the left. Here you can see that the left is pointing to null, but in my case the left is pointing to 6. So here you can see that the definitely right child should be pointing to the null. So we just simply swap them to the right. Here we just simply swap the 6 to the right and null to the left. So we just swap on the third node also. Now we can see that the whole left tree is now equivalent with the root 2 left trees. Now let's move further to the right child. Right child, you can see this 2 and this 2 are same, but the 2's left is 4 and here is 2's left is also 4, and here you can see right is 5, perfectly fine. Now we just came to the 5 node and we can check that does the 5 left child is equal to the root 1 or not. Here you can see that these two are not equal. So here we can again swap them. So we just simply swap the 7 over there and we just simply swap the 8 over there. Now I can clearly see that my whole tree of root 1 is perfectly equivalent to the root 2. Right or wrong? Right. So what exactly we did here? We just simply swap the first root node. Second, we simply the third valued root node, and again we swap the fifth valued root node. So here what we have to do, we don't have to count the minimum number of swaps needed. Here we have to count. We can do just simply in number of swaps, but my ultimate goal is at the last, does my root 1 is completely equivalent to the root 2 or not? Okay, I hope you understand the question right now. So in my case, we can clearly see that my root 1 is now equivalent to the root 2. So we can simply return true. Now let's understand some test cases also. First test case is that you have suppose only one node. Okay, the root 1 is the 1 and root 2 is also the 1. So can you tell me that this root 1 is equivalent to the root 2? Yes, these are equivalent. So you can clearly see if my root 1 value is equal to the root 2 value, and if there is no further child or no further subtrees, then definitely we can simply return true. Right or wrong? right? And suppose that my root 1 is null. My root 1 is null. It means there is no tree on the root 1, and also my root 2 is also null. So can you tell me that these two are equal or not? Yes, these two are equal because null equal to null. So in that case, for root 1 equal to null and root 2 also equal to null, and that case also we can return true. True means simply we can return 1. Okay, we understand these two cases. Can you tell me that suppose for root 1 has only 2 nodes, but on the right subtree has definitely a 4 left nodes. So does these two are equals? Does the two are equals? No, because if we just further move that in this case, suppose that this is 1, and this is 2, and this is 2. So we can clearly see that root 1's value is 1 and root 2's value is 1. So these two nodes are perfectly fine. We just move to the left, and here we can see also that these 2's and these 2's is also equal. So we just simply move to the left. Here we can see that the left is null, but here is left as another node. So in that case, we just simply return false, because in that case my root left child is null, but my root 2's left child is not null. If we simply counter that, if any particular node is null, maybe it's the root 1 equal to null or root 2 is equal to null, and that case we just simply return false. Means any of the root, if it is null and another is not null, then in that case we just simply return false. Okay, good enough. And the last case we just want to survive over there, which suppose that you have given a tree and this tree has same depth, and here we can see this is 1, this is 1, this is 1, this is 1, but and the root node here you can see it is 2 and it is 3. In that case, when the root value is different, root 2 is not equal to the root 2's node, then we can simply say that this return false. We don't know that maybe there is 100 of nodes, there is 100 of nodes, there is 100 of nodes, and there is also 100 of nodes, and this whole subtree is equal, but the root node is not equal. Then in that case we'd never go to the further move, we just simply return false. So I hope you understand all the cases. Now suppose that is everything is fine. What we have a great depth also. It means our left and right child is perfectly not null. Also our root is also the same. Then at that case our main program will be held. Okay, so on that case, that the left child of the tree is not same as the left child of the root tree. So can I tell, in spite of swapping them, this we just simply check the root 2's right child with the root 1's left child. Can I say that? Can I say that? Yes. In that case also we just simply swapping, but in virtually, not physically. So what we have just exactly done, we just checking that the left whole child is equal to the right whole child of root 2. So okay, we can simply check that these two are equal. So after that we are standing over the 2. Now we can simply again check the left child. So does the left child of the 2 is equal to the left child of the 2? Yes, they are perfectly fine. Perfect. Now here you can see there is no values at all. So simply we are just returning, and again we are checking the right value of the 2 node. So we are seeing that the right values of the 2 nodes is also the same. Now we are standing over 5. Again we are checking, does my left child of 5 is equal to the right child of this 5? The answer is no. So we are simply checking again that does my left child of root is equal to the right child of this 5? Yes, they are equal. So we can simply move to the 7 again. So what we are doing, that in that case when the left child are equal, when these both left child are equal, we're just further moving. But when we counter that these two are not equal, then we're swapping them. We're actually not swapping them, we're just checking that does my left child is equal to the right child or not. So here we can see that we don't need to swap. So we just simply call the recursion by sending the root left as well as the root 2's left to the recursion, and if my recursion have returned me true, definitely the solution will be true, and if this is returning me false, then definitely I just did something mistake. So what I'll have to do, I just simply call the recursion again, and we just simply pass root 1's left with the root 2's right. First of all, let's write the pseudocode, then we can simply answer. So suppose that there may be a function which is maybe the solve, and here is we are just passed two parameters, one is root 1 and one is root 2. So the first case may be the base case, and what will be the base case? That if my root 1 is equal to null, and if just simply root 2 equal to null also, then in that case we just simply return what? True. Because if both the tree is null, then definitely we can say that my current tree is perfectly equivalent. Again, we are just simply check that does my root 1's is equal to null or root 2 equal to null. Okay, just understand this perfect line. I'm just saying that does my root 1 is null or root 2 is null. If the both is null, then definitely we can return true. But any of one is null and any of one is not null, then we can simply say that return false. Don't move further. Okay, done. And if the both test cases hasn't been executed, then we can simply say that my both trees node, I mean root 1 node and root 2 node is not null. So in that case, we'll simply check one thing. We'll simply check that does my root 1's values is equal to root 2's values or not. Why so? Because I said that if root values is not the same, then definitely we can say that my tree is not safe. My tree is not equivalent at all. Then we just simply pass these two values. Then we just simply call our recursion. Okay, so first we are going to take without swap. So you can see that in without swap, we just simply move to the left of the root 1 left. We just simply move to the root 1's left child with the root 2's left child, and also to the root 1's right child with the root 2's right child. So what we can do? We just simply call that particular function with the root 1 left child and root 2's left child, and also we're just simply call that particular recursion with the root 1 right child with the root 2's right child. Why so? Because I am having faith if I sending the left child and the left child both trees, then definitely it may be return me true. And also if it is left child is equal, definitely we also have to check also the right child so that the both subtrees are equivalent. And we are having faith that the whole function has definitely written me true or false. So what I will do is just store them with a value which is without swap. Okay. Now the second things we have to done, that suppose that these twos, I mean this left child and this left child is not same. In that case we just simply checking with this left child with the right child of root 2. So we just calling the solve function with the root 1 left child with the root 2's right child, and if it is having same, then we are just also checking the root 1 right child with the root 2's left child. And I am having faith this is also returning me true or false. So I simply store them with swapping. What it means? It means that we doesn't even counter the left values with the left values. So we just move to checking the left values with the right values. Clear? Now we have two answers, without swap and with swap. So it means that some of the nodes need swap and some of the nodes need not swapping. So in both cases, definitely if that any of me, no matter any of me is returning me true, then definitely my both trees are equivalent. So in that case, we just simply return without swap or with swap. This is my problem. So first of all, what I have done, I just simply check that does my both trees are null or not. If the both trees are null, then definitely we can clearly see, okay, I have a mistake over there, which you just simply see that yeah, these two trees are simply equivalent. So in that case we just simply return true. Also we have to check that does any of one is null and the other one is not null. In that case, what we have to do, we have to just simply return false. So we're just simply returning in that case false. Now we just completely with my base cases. We can also further move if my both nodes values are same. if it is not my both true node, root nodes values are same, then definitely we can clearly say that my both trees are not equivalent. So we're just simply moving further. Now we're just doing my operation. What have we done? First I'm saying that I'm just making a function without swap, and what we'll have to do, we have to simply call that function which is flip equivalent, and we have to pass root 1 left child with the root 2's left child. And definitely I am having faith that this particular function will return and check all the values to the left child of the root node. Also you have to check to the right node, right? So we're just simply call that function again, and in that case we're just simply check the root 1 right child with the root 2's right child. Done. Nice. Also I have to check this is for the without swapping, and if this any of the node is need swap, then what will we have to do? We have to call a function for with swap. So again we have to call that particular function at all, and here we just simply say that just please check with the root 1 left with the root 2's right, and if this is true, okay, fine. And also check does my root 1 right child is equal to the root 2's left child. Nice. And now I am having faith that these two definitely give me something return. So in that case we just simply return without swapping or with swapping results. Nice. Now suppose that these two values are not same. My root node values are not same, then definitely we can clearly say that the rest of my trees is definitely not be equivalent. So what we'll have to do? In that case we just simply return false. Let's run it. We should pass all the test cases. I mistake the root to name, so let's again run it. Okay, now let's submit it. Perfect. So now let's understand the basically concept of the now let's understand the time complexity and space complexity also. So here you can see we just basically checking the root left with the root 2's left and root right of the root 2's right. So definitely my first ever recursion, which is root left to the root 2's left, it take me O of n, and also to the root 1 right with the root 2's right, it's also taking n, and same things with the root 1's left with the root 2's right is also taking n, and also same things root 1 to the right and root 2 to the left is also taking n. So whole of my time complexity of this particular function will be O of 4 into n, which is O of n. Now also you can furtherly check that if I'm talking about the space complexity, so in space complexity it doesn't even check it doesn't even take any particular values, but we are just taking auxiliary spaces. So in auxiliary spaces definitely we are visiting every node once, so it's also with the O of n on my stack. So I hope you just understand the problem. If you have any doubts so far, do let me know, and please like, subscribe, and also comment if you understand that. Thank you.